Yes, sir, it is visible.
Thank you. So today we are going to start with we are going to interface some of the display units which we can use in the IoT devices. Like these are not prefixed, like you are going to use these devices into the IoT system, but yes, some of the cases you might be requiring these out. So let us interface these things today. So the first element which we are going to for this display purpose is the 7 segment display. Fine. Just a second. 7 segment display. So when we consider a 7 segment display, so like basically what it is, it's basically the arrangement of 7 different LEDs into a form of a figure of a 8. And by turning on a particular element, which is basically known as the segment into the 7 segment, we are going to display different type of numbers in it. Fine. So there are multiple segment displays. Like you can have a 7 segment display, you can have a 10 segment display, you can have 14 segment display. It depends upon the uses as well. Fine. And the next thing, next category of this 7 segment display is whether they are going to be a 7 segment display, a common cathode or a common anode. So as we know from the first lecture, from the second lecture about the LEDs interfacing, we know there can be two ends of a LED, either the cathode end or the anode end, either the negative end or the positive end. So the common cathode means we are going to have a common end for, like, we just going to have a single pin, single ground line for every LED for the each 7 segment LED and a dot LED. And a common anode means like we are going to have a same power line for a power supply. Like in this case, you can see this is the example of a common anode type. Fine. So common anode type. So this is the main figure, and when these 7 segment displays can be used to basically print from up to hexadecimal, like from 0 to 9, and from that A to F. Fine. So this is the basically in some kind of a counters, if some kind of like alert systems in the IoT devices, you can have a use of it. The main problem about this 7 segment is like it is going to use a lot of pins from the IoT device. So like most of the time it might be useful for those people who can just want to display some number, which can be easily done by a decoder as well or an encoder as well, a 7 segment display decoder or an encoder. But some cases what we can do is we require the direct access of each pin. Then there is some kind of issue because these are going to have a 7 different pins at least to be utilized to display the segment. Fine. If you are going to use a decoder, then the number of pins will be reduced. That's for sure. So let's see how this is going to work. So for that, we are going to require we are going to have two exercises in this. So for that, we are going to require Arduino Uno with the USB cable, a 7 segment display. This can be a common cathode, this can be a common anode. It's totally up to your choice. Jumper wires, breadboard, push button, and the 1 kilo ohm resistor is will be the optional for the second exercise. Yes, also we will be requiring a 220 ohm resistor as well for the 7 segment display, so that like if these are also LEDs and they also require to be like we have to limit the current which is going towards the LEDs. Fine. So let's just see the diagram, like how we are going to basically interface this out. So we are first going to insert the 7 segment display into the breadboard, and then we are going to connect the negative rail of the breadboard to the ground of the Arduino and the positive rail of the breadboard to the positive rail or the 5 volt supply of the Arduino. Fine. Now in this I am using different pins like 1, 2, 3, 4, 5, 6, 7 for the 7 segment. You can use any different pin and like any different combinations. We are going to code in such a way like you don't require to change the code every time. You just require to change in the upper section which segment is being attached to which number of pin. That is the main thing which we are doing going to do, so that if we have any kind of modifications, we don't require to change everything every time. Fine. and like this is the main connection. Like this is going to be the seventh pin, and this is going to be connected to pin number A of the like or the segment A. Like when we see into the 7 segment display, you can see we are having different segments, and these are being labeled over there like segment A, B, C, D, E, F, and G, and we are having the pin number associated with that segment. So we are just going to code that thing over there, and like with the example, like with when we are going for the simulation part over there, it is more clearly visible. That's why how we are going to generate the patterns we'll be discussing over there itself, including the like when we are going to do the coding as well. Fine. So let's just move towards the coding part. And to be honestly speaking, there is nothing new in this code. Like it's just as simple as we have interfaced an LED in the previous lectures. So before that, let us have like let us define that criteria, so that if we want to change the segment pin which is going to be connected to the Arduino, like if we suppose like I am going to connect for the first time, I am connecting the segment like the pin number 0 to segment A, but after some time I want to connect the pin number 2 to segment A. So in that case, what happens if we do not define that logic into the starting, then we require to change that thing every section of the code. So it's better we just define that thing first. So how we can do is we can just use these keywords like define, and let us this segment A to be, this is going to represent the pin number which we are going to use. So in this example, we are going to use the pin number uh, 2 for suppose, and the define statement will not be requiring a semicolon at the end. You can just go with this itself. It's just go for the declaration part or telling Arduino the compiler what this A represents. Fine. So let's just do this in that way for each segment. We have B, C, D, E, F, and your G. I'm going to connect in a serial order from 2 to 8, I guess. So like you can use any different combination you want to have in. Just a sec. 4, 5, 6, 7, and 8. Fine. So we have defined that pin number. So let's come back. This is the main thing which we want to done, so that like now in case I want to change my pin number for like the for element A, I want to change it to pin number 0. I can just do it over here. I don't want to change it in the entire code. So like at present it is 2. Now in the void setup section, what we are going to do is we want to tell Arduino like which pin will be the input, which will be the output, and which pin we are going to use. So for that we know that we require this function, the pin mode, and in pin mode. But previously what we are doing, we will be passing the pin number and the status, like whether it is be the input or the output. So in this case, what we can send is the character A, which we have defined to be as pin number 2. So wherever the compiler will be checking the code, it will be translating this A to a integer value 2, and that is being basically used like the pin number 2 of the Arduino is going to be the output, since we are going to interface a LED itself. The 7 segment is a segment, and the segment is basically a normal LED. So that's why it is going to be an output. Again, in the similar basis, let's just this whole up. B, C, okay, D, E, and your G. So this is what we require in the setup section. We have defined our pins, right? Now what we require, let us not basically write the code like for the each segment we are going to display this. Let us make different functions for each segment to be displayed out. Now how they are going to work the segments out, let us see first that thing. Like in this example, if we like suppose we want to display one, how we can display it? Like I am taking this is the example of common anode. We are going to work on a common cathode. Like the ground line will be common, and we are going to supply the 5-volt supply to the pin so that it can turn on. So in this case, like we are going to have a 7 segments. Now if we want to turn on, like we want to display a 1 to the 7 segment, what we require? We require to turn on segment B and segment C. So I guess you can basically relate this thing to be a display of 1. Fine. In this way, we are going to code for everything. Like what this supposed to tell us, like all the other segments, segment A, G, F, E, and D are going to be low. And for segment 1, for segment B and C, we are going to display it high. That is the main simple logic to display 1. And similarly, we are going to do for the each number. So let's make the function first. So we have in this case, we are not going to send any other value back to the main function, which is going to be the void loop function. We are just going to send the like command. We just want to call that function out. So in this case, we require the void as the keyword or the data type, which like the function return type to be as of void only, because we are not going to send any, we are not going to return any value back. Fine. So in void, we're going to have a name for the function as display underscore one. Do not like just override with the keyword. Display is a keyword pre available into the compiler for the Arduino. So we have to change it. So let's make it as display one. We need some braces over there, and then we need the curly brackets code. Now let's write the code. It's digital write, as we all know. Now what we are going to do, we know that the segment A is low. Then let's just copy this first. Copy, 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 copy. C, D, E, F, and last is our G. So as we see in the diagram, we require the pin B or the segment B to be high to display 1, and the segment C to be high to display 1. This is the code for segment A. Now, with the help of this function itself, what we get is like we do not require to type this code every time. We just need to, whenever we want to display one, we just need to call this function itself, and the one will be displayed on our 7 segment. Fine. So let's just copy this thing and write the code for 2 itself. Just do it for low so that we are not being confused with the thing. It's for 2. Let's again see what we require to have for 2. So for 2, if we just go with this, we want a segment A. Mhm. Just a second. a segment A to be turned on, B, G, E, and D. So what this shows us, it's a pretty good example for a segment 2 or the number 2 to be displayed on the 7 segment. So what it shows us, like the segment F and C are to be off, rest all are to be on. Fine. So let's just code for that. We require high. B is also going to be high. C is going to be low. D is going to be high. E is going to be high. F is low. G is also going to be high. Fine. So let's just copy this up and paste for 3 itself. So in case of 3, what we require pin A to be high, pin B will be high, I guess. Yeah, it should be. Pin A, pin B, pin G for the segment G, C and D, which shows F and E will be off. So F and E will be off. Let's just do this for them. Fine. So in this case, we are able to make for the code for the digit 3 as well. Let's just have it for 4. For 4, what we require? We require segment F, B, G, and C. So A, E, and D are off. A, I guess E and D are off. F was on. Fine. In similar way, we can go for 5 as well. For 5, what we require? A, F, G, C, and D. So segment B and E are going to be off. Segment B and E. B is off, already off. We require F to be turned on. Fine. So let's go for C as well. Sorry, for 6 as well. So what we require over here is for 6, like we just need to turn on the E segment. Rest the code is same. Let's just turn on E. For 7, let me just copy the code for 1. Then over here, we just require to turn on the A segment. How it goes? It goes like this: A, B, and C only. Fine. Let's just copy this and paste it again. Now we are left with 9 and I guess So we have done a mistake over here. We need to change it to 7 as well. Now it's the turn for 8. So let me copy 6, because in 8 every segment is going to be high. For 9, what we require? For 9, we require A,
Except
B,
D, all the segments.
exactly, except E, all the segments are going to be turned on. This is for 9, and for 0, like it's just the G segment which is not going to be turned on. So this was like we have coded for each and every number in it. Fine. If you can go, if you want to go for the A, B, C, D, you can just go for that as well. Now what we are going to do is we are just going to call these functions one by one. Like how we are going to call it, like just a simple this thing, display 1, like let's start with 0. I'm just going to copy this for 10 times, or we can just like have a loop for this, have a loop for this. What we can do is we can go with a for loop in this case, and the for loop is from int I equals to 0, I less than 10, I plus plus. So like for those who might if you are not aware with the for loop, like whenever we have a case in which we are known with how much time, like for how much iterations or how much like turns the system is going to work, then we can go with a for loop. And the for loop structure is like we need to require a variable which is going to be starting with the initial value, then the condition till this loop is going to be turned on basically to work, and the last thing is whether we are going for an increment or a decrement to basically know the next value. Like suppose I am going for in this case I am just checking like till the time my I values reaches 10, you can go with the function inside it. Fine. After that, just move out from this loop. It might be case you want to just want to basically display about the even numbers only. Then you can just shift this part from I equals to 1, I equals to I plus 2. This can also be the case. And you even it is possible to like basically start this thing from 9 and make a loop in the opposite direction till the time it is greater than or basically greater than equal to 0, because we want to display 0 as well. Fine. And if that is the case, then you have to basically change this sign as well. You have to basically do that into a negative loop. So minus minus will be in that place. Let's just have this as I. Let me take it like I don't know whether it's going to work. Let's have the fun. After that, we require a delay of I guess 1000 milliseconds. So that will be pretty enough to have. Let's just save this if we are good to go. Yes, we are good to go. Now we are going to just check for the input. Int val equals to digital read 12 in this case. Then we are going with a serial. Oh, sorry, we are going with the if statement. If val equals to high, then what we are going to do is we are going for a while check. If digital read 12 is equals to high, जब तक ये high है till the time we are going for a while loop itself. After that, just going to go for the count to UND plus 1. Fine. So let's just see if it works this time. Still, so now it is working. Sorry for the trouble issues. Like what I have done the mistake in the starting was when I was having this two brackets into a similar line, single line, and I put it this columns. This second braces was also considered to into the comment section itself, and that is why we were having a bunch of errors in that. Our code was perfectly right, there was no mistake in that. Just because of that issue, the code was giving errors. Now let's just start with this point again. So initially we are having the point 0 since we have initialized a count value to 0 itself. Fine. And then when we press this button, till we are pressing, there will be no change. As we release this button out, our value changes to 1 and we have a display of 1 over this side. Fine. Now, if we want to display the rest of the numbers, we can display that too as well. Let me just copy this code up so that we don't get these error lines. Or what we can do is we can have a simple functionality for this itself. We know that we are using the count value. What we can do is we can use this structure statement or the switch statement itself. What it is going to do is, now let us see that thing up. This switch statement, okay, now I'm not going able to. Wait a second. So there are trouble of using this. Okay, now what we're going to do is we are going to have a switch block in this case. So you remember that thing we were writing again and again, the if statement and the if else statements, else if statements for different cases. What we can do, like this is we know that the dependency of this change in character or the change in the display is dependent of that count value. So we make a switch case on the basis of that, like if there's a case 0, suppose the value of the count is 0, so we will be displaying 0 itself. If that is 1, that is 2, that is 3, and we are going to display the corresponding number itself. Fine. And then there is a default case. In default case, what we require, like if the upper cases are not satisfied, we are having some extra different case, then we are going to have this kind of a structure. Now after this structure, we can also consider that thing out, like to again start the loop, we can have if count is greater than 10 or 9, we can basically change that count to 0 itself. Let's just run this thing. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and again we are having a 0. Sorry for those errors, like that was my mistake. And now if there is any doubt, please let me know. If you want a redemonstration for these all things, we can have that too as well. Anyone having any doubt, please let me know. I don't know why I have done that mistake, but okay, it is done. So no worries in acknowledging that mistake. Fine. So if there is any doubt, please let me know, or it is clear with your point. And if like we were having this issue with this push button in the case of when we are just turning on and off the LED on the basis of single push button. So over there, you can also add this functionality of the while loop in order to remove that debouncing effect. Fine. And if you are having doubts, you can ask, please. Anyone? Anyone having any doubt, please let me know. No doubts?
No, sir.
Okay. So this was the issue for today. Let's then move towards the next exercise. The next exercise we are having with the LCD display. Now in the LCD display, what we can see, this is basically a liquid crystal display. Now how it basically works is we will be having a loud light source beside this mirror, and with the help of these filters and the negative areas, the light reaches to this polarization film, or after that polarization film, we reaches to this liquid crystal area. Now this liquid crystal is having the ability, like with the light affecting and with the current into that particular position, it will act as like a semi solid substance as well. And on the basis of that, we are going to see the different uh, character, we can say different digit, which is going to be displayed over here. Fine. Now, like for the LCD, this is known as the 16 is to 2 LCD, which is a very common one, which is used in the like embedded systems. You can have different variation of this as well, like 16 is to 2, 16 is to 10, 16, sorry, 16 is to 4, 20 is to 4, and so on and so forth. Fine. This is another issue with this LCD as well, like we have seen for the 7 segment, like the number of pins required to interface are large. Fine. Like you can see, like this is the ground. Okay, the 5 volts is okay. Then we require a contrast pin. Then we require a resistor select pin, a read write pin, enable pin, then the D0 to D7 pin, and the backlights. So this requires a bunch of pins. Now there are multiple modes which we can use for the LCD to interface. There is a 8-bit mode and a 4-bit mode. In the 8-bit mode, all these D0 to D7 pins are being utilized. If that is not the case, you can use the 4-bit mode. In the 4-bit mode, what we can do is we can use from these 4 to these 7 pin to display a particular character or a string to the LCD itself. Fine. Now, this contrast pin, when we talk about this contrast pin, this is basically used to select about the brightness or the contrast of a particular character, what we are going to display onto the LCD. Fine. This register select pins basically helps to check whether we are sending a command or whether we are sending a basically a data. Suppose like what happens is that in this LCD we are also having some microcontrollers inbuilt in it, and that is having a register, a control register and a data register. The control register is specified for the control purpose. Like you want to clear the LCD, you want to basically display into the second line, you want to change the line, you want to make the cursor to turn on, turn off, like the cursor should be blinking, you want the cursor to be off, you want to basically just move into the move into the back column, you want to change the column, you want to change the row. So all these functions are basically the control functions, and the data register will be storing the data which we want to display on the LCD. Is that like that can be any character we want, will be sending to it. Fine. And this enable pin is basically just to be like enable the LCD microcontroller itself. Now there is also a back LED or back light source available with the LCD, which can be turned on with this backlight cathode and backlight anode function. Like these are basically the direct power supply connection. We are not going to directly control these two pins with the Arduino. Fine. And this read write option is basically if like the most of the time we are going to write to the LCD itself. We want to display something out, so we are going to just write to the LCD. And if in some cases you want to read the previous data being available into the data register, you can also use this read write pin as a read pin only, and to retrieve that data out from the microcontroller register available into the LCD itself. Fine. So for this interfacing, we will be requiring an Arduino Uno with the USB cable, 16 is to 2 LCD or any LCD you want to have, a 1 kilo ohm potentiometer. This potentiometer is basically being utilized for that contrast purpose. Fine. And jumper wires, breadboard, and a 220 ohm resistor. So this is how we are going to have the connections over here. Like it seems to be difficult, but with this diagram, you can easily do that out. Like first of all, we are going to insert the LCD into the breadboard. Then we are going to connect the positive rail to the 5-volt supply and the negative rail to the ground supply of the Arduino. And then we are going to connect the first pin, which is the VSS, to the LCD's negative rail. The second pin, which is the VDD, to the positive rail. The third pin is your VE, which is the contrast pin. It is going to be connected to the wiper pin of the potentiometer. Fine. Then we are going to connect the other like okay, this is the next two connections are for the potentiometer itself. The one pin is going to be the ground pin, and the other pin is going to be for the positive 5-volt supply. The fourth pin is the RS pin or the register select pin, which is going to be connected to pin number 12. Now these four pins, like the register select pin, the enable pin, the pins for your digital commands or the digital purpose, like for the data transmission, can be selected on the user basis. You want to use these pins, you can use it. You want to change these pins, you can definitely go to change these pins itself. Fine. So the register select pin is connected to pin 12. The read write pin, as I have told, like most of the case we are going to use just for the write purpose. So we are just going for the connecting this pin to negative rail of the breadboard itself. Fine. Now we are going to connect the sixth pin, which is the enable pin, to the 11th pin of the Arduino. Then the pin D0 to D3 will be left, since we are just going for a 4-bit mode itself. Then D4 pin is going to be connected to the fifth pin of the Arduino, D5 to pin number 4, D6 to pin number 3, and D7 to pin number 2. Rest is just your backlight connections. Fine. Let's just make its code and hope we do not do any mistake in this case. So since like LCD, there are multiple functionalities still available to control an LCD. Like to write something to the control register, there is a sequence of steps. Like the first, the enable pin will be going from the high pulse to the low pulse for a particular time cycle. Then we are going to send the data. Then we are going to first send the control data. Then we are going to send the data which we want to display. So this is little bit complex for a newcomers to handle. That is why this Arduino is also giving the availability of different libraries. And in this case, we are going to use that particular help of the library to interface the LCD itself. So let me just add that library into our code itself. So for that, what we require is hash include liquid crystal dot h. Fine. So this is a library which we are going to use. Now let us just define those pins which we are going to connect with an Arduino, so that in case if we want to change those pins, it will be easier for us. So let's just write for that, like the RS pin, as according to the diagram we have connected to the pin number 12. Then we have the enable pin, which was connected to, I guess, pin number 11. Then we are having the D4 pin, which was connected to 5 pin, the 5 pin to pin number 4, the 6 pin to pin number, I guess, 3. Yeah, it's 3, and the 7 pin pin number 2. Fine. Now we require, whenever we basically include a library, we require its object to be initialized, and for that, first of all, we require to basically define a object for that. So for that, we require the name of this LCD, this library. It's liquid crystal. Then we can just add it the name as LCD. Then we need to send the parameters to this LCD object to tell which is the RS pin, which is the enable pin, which is your D4, D5, D6, D7, and all those functions. Now just make sure, like, you can write this in any case, any number, doesn't matter. The thing which we are going to write into the LCD bracket function or the object function, that remains to be same. Like that needs to be same. Like the first pin is going to be your RS pin, the second pin is going to be your EN pin, the enable pin, and then your D4, D5, D6, and D7, your 4-bit digital numbers. Fine. This is how we basically initialize the object. Now we need to begin that object as well. Like basically we just have declared that we have an object of LCD with name LCD only, and then we require to begin that object, like as we do with the serial dot begin function. We require LCD dot begin, and then what we require, we need to send a parameter to this as well to tell what type of LCD we are going to use. Like it can be, as I have told you, it can be 16:2, like 16 different columns and 2 different rows. Fine. It can be 20:4, 20 different columns and 4 different rows. So in our example, we are using a 16:2. So let's just pass that as 16:2. Fine. Then if we want to just display something, we just require this command, print lcd.print. What we want to print? Let's suppose we want to print hello world. Let's just have a delay of 1 second and go for the loop section. Let's basically, mm, okay, let's make a for loop. Let's make a countdown for that. Starts with value with 10 till the time it is equal to 0, less than equal to 0, or basically greater than equal to 0. Then we require I minus minus. We are going to have a negative loop for this case. LCD dot. Now, why I'm basically clearing this up so that we can move to the, like every time we can have a similar position to that location, and that is the main reason why I am going to put the cursor line to the next, as in the loop section. We are going to change the line, like this hello world will be printed on the first row, and the next this numbers which I am basically going to send is, I forgot to put I over here, numbers into the next line. So for that we just require the print function with the value I. And if we want basically to change that line out, we require to send a command which is lcd dot set cursor, and it is also going to say take the same parameters, like the first parameter is your row and the second parameter, the first parameter is your column and the second parameter is your row. So in my case, in our case, basically it's 0 comma 1. We are going to change the row. So the second row is basically, it will be starting with the index 0, so that is why we are having the second row to be represented as 1. Fine. And let's just have a delay of 1 second in this case to see that change as well. And what we can do is, we can just now we can clear the LCD, the column to 4. This is to be 0, and then we can just print something else, like say last off, anything you want to write. It's totally up to you. Like it depends what we are doing. It's just for the interfacing purpose, so we can have it. And then let's just put a very small delay in this case. Fine. So let's just check for the code if we have done any errors. Hope not. Yes, we haven't done any errors. Let's just go to the Arduino itself. Let's go to the Arduino all, and so if you go with that same number or the same connection pins, you might not be requiring to have the make the connections, because Tinkercad is also already having the LCD into it itself, and the connections are already the same. Like if you want to change that, you can do it. It's totally up to your choice. And it is also basically like the, you will be having the practice as well. Now let's just put the code into this and let's just see if this works or not. So hello world, and we are having the change into the column as well and the row as well. Now we are having the countdown. Let's see where the blast off goes. It goes to the first line and the middle. So this is how we can interface an LCD. Now, in case you want to not to basically just do this normal stuff, like this is not a genuine stuff, but we are doing it's not on us. Like it's we are just printing anything we want. Suppose we are having a potentiometer with us. Int val equals to analog read to pin A0. We get the value, the potentiometer value, and what we can do, we can just print that value as well to the LCD. LCD dot println print to the LCD val, and let's just have a very small delay of 500 milliseconds. Let's just take a potentiometer from here. Okay, so we have the potentiometer. We connect this line to ground, this to positive, and then we can have the connection from this side. Let's just play with this. We're having a 0. Okay, so like this is why that this I want to see this thing as well. We are not putting any clear function in that, and that is why it is keep on printing to the LCD. That is the main reason why I was putting that clear function, so that we are having the display to that simple or the similar position itself. Fine. Let's just have that clear function as well. LCD dot here. So we have a 0, then we can have the value from 0 to 1, 0 to 3. In this way, when we are going to basically interface any sensor, we can do that as well. So if you want to display that thing to the serial monitor, you can do it. If you want to display that thing to the LCD, you can also do it. Fine. So if there is any doubt till this point, you can ask. Otherwise, we can just have a second exercise with this, in which we are basically going to have a auto scrolling functionality. If you want to basically display, like you want to display something which is going to be like auto scrolling all the time, how we can do that? We will be seeing that. So if there is any doubt regarding anything till this point, please let me know. Anyone having any doubt, please let me know. Any doubts? Anyone?
No, sir.
Okay. So let's just go for the auto scroll functionality. Like it's a very simple thing to do. Very, very, very simple thing. So what we can do is we can have, let's first basically set the cursor. And the cursor is set to pin number 0 comma basically the column 0 row 0, either the very first element. Let's just print something character by character. If I just want to print a hello character by character, how can we do this? H. Let's have a delay in that. Very small delay of 500 milliseconds. E L L O 0. And then what we can do is we can just basically go for the complete letter as well. So like if you want to send something letter by letter, you can do that as well. If you want to just send the complete thing, which we already have seen how we are sending the complete string. Fine. And then let's just have a very small delay of 5. Let's have just a delay of 100. And then we are going to have the auto scrolling functionality. Let's just copy this. Let me just check before if we are having any mistakes or not. So it shows done compiling. We do not have any mistakes. We are good to go with this. Okay, we just missed something out. Ah, we don't require this time. This time. HELLO world, and then we have a auto scroll functionality. It will be coming in a while. Like all the characters will be moving. That's why it takes some time to come. Fine. So this is how the auto scroll functionality works.